Okay, so here's my Charles's Law lab set up. So the first thing I did is I took this syringe and I put it at 30 degrees, and I'm going to do 30 milliliters. I'm going to do that for each student. For each group, I have a syringe for them prepared in advance that is at 30 milliliters, and then I put it in the freezer. Now the freezer is at negative 20 degrees Celsius, I believe. I put a thermometer in there and find out. So as soon as I pulled this out of the freezer, I immediately capped it off. So I have my first data point, negative 20 degrees Celsius and 30 milliliters. Okay, then I immerse it in this water, which is ice cold. I just drain the ice off of it, and so I immerse it in the water, and I let this, sit. Maybe I'll stir it around a little while like this. Now the hot plate's not yet on. The hot plate's not yet on. So this is icy water. I'm going to use my thermometer to just make sure it's still pretty cold. Okay, so let's see here. All right, yeah, it's close enough to zero for government work, right? I've drained off the ice because I just want the water part. You could use the ice if you want, but the ice is you don't want the ice for the rest of the lab after this. Okay, so now what I do is I'm going to check out my reading on my syringe, and we can see that it did expand a little bit. It's not pointing quite to 30 anymore. It's expanded a little bit from 30. Okay, it's expanded a little bit from 30. I'm going to try and get this where you can see it. Let's see if we can clean that up a little bit. So can we see that that's a little bit above 30? I'm trying to see that that's a little bit above 30. Let's see here. Okay. So can we see yeah, there we go. It's a little bit above 30. Okay. So what we did was we just immersed the syringe in the cold water, but the ice cold water is still warmer than the freezer. And we just did this until we saw a decent amount of expansion. Okay, let's see it there. And then we're going to write down that new amount of volume. We're going to write down that new amount of volume. Now I'm going to turn on the hot plate, and I'm just going to let it warm up for a little while. Okay, and so what'll happen is that as the hot plate warms up the water, then the syringe gas will get warmer and it'll push out. And so maybe I'll take data at 20 degrees Celsius, 40, 60, 80, and all I'm trying to do is get different measurements of volume at different temperatures of the water. Now, let me show you an important trick, which is this. And I did this off camera, so I need to make sure you see it. These pistons in the syringe have an extreme amount of friction. So after this has gotten up to a certain temperature, in order to figure out what the piston is actually trying to point toward, I'm going to do this trick to try and negate the friction. I pull the piston out. This is very important. Try it yourself. I pull the piston out, and let's see what the piston goes back to. It recoils back to 36. I push the piston in. Now, when the piston comes back, it recoils to 34. So I pull the piston out, the piston returns to 36. When I push the piston in, the piston only returns to 34. That means that the true reading on the piston should actually be 35 milliliters. So that's a trick in order to try and compensate for the friction in the piston, is let this get up to a certain temperature, then immediately push in and see what it recoils to, pull out and see what the piston recoils to, and then the average of those two numbers will be the volume that you should record. Okay, let's take a look at some data.